Why the space shuttle worked. 1. Reusability. The space shuttle was the world's first reusable spacecraft, significantly reducing costs compared to traditional expendable launch systems. Each shuttle was designed to return to Earth and be refurbished for future missions, with its solid rocket boosters recovered and reused. This innovation allowed NASA to conduct 135 missions over its 30-year lifespan, supporting critical projects like the construction of the International Space Station, ISS, and the deployment of satellites, such as the Hubble Space Telescope. By reusing parts of the system, NASA paved the way for modern reusable spacecraft like SpaceX's Falcon 9, proving the concept's feasibility. 2. Versatility. The space shuttle could perform a wide range of missions, from satellite deployment to scientific research in low Earth orbit. For example, it was instrumental in servicing the Hubble Space Telescope, which extended Hubble's lifespan and significantly advanced astronomical discoveries. Additionally, its payload capacity allowed the shuttle to carry large modules and supplies for the ISS, demonstrating its adaptability in diverse roles. Why the space shuttle failed. 1. High costs. Despite its reusable design, the space shuttle's operations turned out to be far more expensive than initially anticipated. Each launch cost an estimated $450 million, far exceeding early projections. The extensive refurbishment required between missions, including replacing heat-resistant tiles and inspecting reusable components, consumed substantial time and resources. This financial burden limited the frequency of missions and made the program less sustainable compared to more cost-effective expendable launch vehicles. 2. Safety concerns. The program suffered two catastrophic failures: the Challenger disaster in 1986 and the Columbia disaster in 2003, resulting in the loss of 14 astronauts. Both accidents exposed critical flaws in the shuttle's design and operational processes. For instance, Challenger exploded due to faulty O-rings in its solid rocket boosters, a known issue that was overlooked. Similarly, Columbia disintegrated during re-entry after foam insulation struck its thermal protection system, revealing a lack of safety redundancies. 3. Limited reach beyond low Earth orbit. The space shuttle was restricted to low Earth orbit, making it unsuitable for ambitious missions to the Moon, Mars, or beyond. This limitation stemmed from its design priorities, which emphasized versatility and reusability over interplanetary exploration. As a result, while it supported important research and construction efforts in orbit, it fell short of advancing NASA's long-term exploration goals. Programs like Artemis, focused on lunar exploration, have since moved away from the shuttle's approach to address these shortcomings.